All right, section 3 is all about solving quadratics. And we're going to be solving quadratics with our quadratic formula this time instead of by factoring or by graphing. Now, a quadratic equation, remember, is any equation of the form ax squared plus bx plus c. So it's a trinomial. There are three terms, 1, 2, 3. It is all set equal to 0. It's very important that it's 0, that the whole thing equals. Now we have a as a coefficient, b, and c. C is just a constant value, so there's no actual number, or should I say there's no variable, it's just the number there. B is the number part, or the coefficient that goes along with x, and this is x to the first power, and a is the coefficient that goes along with x squared. So if there's no number in front of the x squared or the x, you think of it as a 1. It's like 1x squared or 1x. But again, a, b, and c are just those numbers that we're looking at. Those are what we used to factor before. Now when we use the quadratic formula, we just plug those numbers, a, b, and c, into this formula. X equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2 times a. Now the thing with the quadratic formula, it always works. Now factoring doesn't always work. It can be kind of hard to factor some of our quadratic equations, but the quadratic formula will work each and every time. You want to use this when you can't or you just don't want to factor. Before you can start using the quadratic formula, you have to make sure that it is in this form, that ax squared plus bx plus c equals 0. If it is not equal to 0, it won't work. And you will always get two answers. One where you do this whole thing with the plus, one where you do this whole thing using minus. We have to use plus and minus because when you take the square root of something, so right up here in this part of the formula, it's the square root of all of this. Well, we can think of it as maybe like the square root of, let's say, 16. Well, the square root of 16, there's actually two different values. One would be 4, because 4 times 4 is 16. The other one would actually be negative 4, because negative 4 times negative 4 becomes 16. So square root of 16, there's actually a positive and a negative value. That's where this plus and minus comes from. So there will always be two answers. Leaving them as exact answers is the best. So let's look at some examples of how this works. So examples of the quadratic formula. Again, you need to make sure it's ax squared plus bx plus c equals 0. In our example, 3m squared minus 4m minus 64 equals 0. That already is in this form. We're not using x's, we're using m's, but it is still already in this form. So according to this, our a value is 3. It's right in front. Our b value is negative 4, because minus 4 right here. Our c value is negative 64. That comes from right here. Now using these values, here is that quadratic formula again. Negative b plus or minus square root b squared minus 4ac. All of this divided by 2 times a. So we just plug in our values. Negative 4 comes into this piece, so it's negative 4, plus or minus the square root of negative 4 is what's being squared, minus 4 times 3 times negative 64. All of this is over 2 times 3. We just took this a, b, and c value and plugged them in accordingly into those spots. Now we're going to start simplifying each of those pieces. Negative 4 is a positive 4. Negative 4 squared is 16. 4 times 3 times negative 64 is a negative 768. 2 times 3 becomes 6. So right now, as we simplified, this is what our formula looks like. Simplifying even further, 16 minus negative 768. When you subtract a negative, that's like adding. So underneath the square root, it's now a 784. So 4 plus or minus square root of 784 all over 6. So from here, square root of 784 is actually 28. So it's 4 plus or minus the square, or 4 plus or minus 28 divided by 6. This is where, now that we have it all simplified, we break it down into two different answers. One where we do 4 plus 28, which is 32. So it's 32 over 6. Or one where we do 4 minus 28. That would become negative 24, still over 6. So in the end, we have two answers. We'll use these fractions and simplify them. 32 divided by 6 we can take 2 out of each of those and call it 16 thirds. So I guess in this case it would be an m. M equals 16 over 3, or m equals negative 24 over 6. Divide that, we would get a negative 4. So in the end, we will have two answers, negative 4 or 16 thirds. Those would be the two different answers to that quadratic formula, or the quadratic function. Now again, that would be the same as if we were to try to factor it out. There are always going to be two different factors, so there are two different answers. That's why we have two different answers when we use quadratic formula as well. Let's look at another example then. We will do 5v squared minus v minus 118 equals 12. Now we always want it to be set equal to 0, and it is not. So from this one, before we can do anything, we have to subtract 12 from both sides. When we do that, our formula, our equation now looks like this: 5v squared minus 1v minus 130 equals 0. So now we are in that quadratic form. So a is 5, b is negative 1, and c is negative 130. So again, we just plug those all into our pieces. Here's our quadratic formula. We plug in each of these values for a, b, and c. So we'd have negative 1 plus or minus the square root of all of this piece. Negative 1 squared minus 4 times 5 times negative 130. All of that is being divided by 2 times 5. Simplifying that piece, negative 1 would just be positive 1. Negative 1 squared becomes 1. 4 times 5 times negative 130 becomes negative 2,600. And 2 times 5 is just 10. Simplifying even further, we have 1 plus or minus. 1 minus a negative becomes like an adding, so 1 add 2,600 becomes 2,601 underneath our square root. And it's still all over 10. Simplifying that even further, square root of 2,601 is 51. So we have 1 plus or minus 51 all over 10. Simplifying that, we'll do one case where it's 1 plus 51, which became 52 over 10. We'll do one where it's 1 minus 51, so it's negative 50 over 10. Simplifying each of these fractions then, 52 over 10 becomes 26 over 5, which take 2 out of each of them, and negative 50 over 10 becomes negative 5. So these would be our two answers for our quadratic equation. Looking at another example, we've got 6n squared plus 4n minus or equals negative 3. This is kind of similar to our last example. We don't have it all set equal to 0, so we're going to have to add 3 to both sides of this equation to make sure we have everything set equal to 0. When we do that, it now changes to 6n squared plus 4n plus 3 equals 0. So looking at all of that, our a is going to be 6, our b is going to be 4, and our c is going to be 3. Using these values and plugging it into our quadratic formula, it's going to look something like this. N equals negative 4 plus or minus the square root of 4 squared minus 4 times 6 times 3. This is all going to be divided by 2 times 6 then. Simplifying that, we would have negative 4 on the outside plus or minus the square root of 4 squared makes 16. 4 times 6 times 3 becomes 72. So underneath our square root we have 16 minus 72. And this is all going to be divided by 2 times 6 makes 12. Simplifying underneath the square root, we'll have 4, or negative 4, plus or minus the square root of negative 56 all over 12. Now at this point, we will notice we have a square root of a negative number. We cannot do the square root of a negative number. There is no real answer for that. Whenever you have two numbers being multiplied, whether they are positive or negative, they will come up to a positive answer. So square root of a negative is impossible. So at this point, you would then call it no real solutions. There are no real solutions to something like this. On your homework, though, I want you to actually write in what you got. So you would circle all of this together. N is equal to -4 plus or minus square root of -56 all over 12. This is still technically your answer. You would use that to say that there is no real solutions. So this is all kind of technically one big answer together. All right, in our last example, we've got 6k squared minus 8k minus 79 equals -7k minus 9. This is obviously not in our ax squared plus bx plus c equals 0 form. We're going to need to add 7k onto both sides. As well, we need to add 9 to both sides. When we do that, it becomes 6k squared minus 1k, because we added 7k to both sides, minus 70, because we added 9 to both sides, equals 0. Now we are in our quadratic form. From there, we can then say a is going to be 6, found right here. B is going to be -1, found right here. C is -70, found right here. Using these values, we again just plug it into the quadratic formula. K is -1 plus or minus the square root of -1 squared minus 4 times 6 times -70. All of this is being divided by 2 times 6. Simplifying that down, -1 is just 1. -1 squared is 1. 4 times 6 times 70 is -1,680. And 2 times 6 makes 12. Simplifying under our square root, 1 minus a negative will become adding. So 1 add 1,680 is 1,681. And it's still all over 12. Simplifying that down, that square root is actually 41. So we have 1 plus or minus 41 all over 12. Simplifying that then, this is where we break it into two pieces. Either 1 plus 41, which makes 42, or 1 minus 41, which makes -40. In each case, it's still over that 12. So we would simplify that fraction then to say 42 over 12 is 7 over 2, so k can either equal 7 halves, or -40 over 12, we take 4 out of those, and we'd have -10 over 3. So these would be our two answers to that quadratic formula or equation. So that would be solving using the quadratic equation. Now in the next video, I'm going to show you how to plug this directly into your calculator to solve it out for you.